Hello students, myself Sarama Malik, Assistant Professor of Gargi Memorial Institute of Technology. Today I discuss about the application of triple integrals. In my previous lecture I discussed about how to evaluate the triple integrals. So here we discuss about the application of these triple integrals. Triple integrals has a various geometrical and physical application. Okay, so it is used to find the volume of geometrical substances over the domain D. Now let rho of x, y, z be the volume density distribution over D, then the total mass of the whole solid region, which is contained in D, is given by M is equals to triple integration over D rho of x, y, z dx, dy, dz. Okay, so this is our triple integrals. Now when rho of x, y, z is equals to 1, then the triple integrals over D represents the volume V is equals to integration over D dx, dy, dz. Okay, and the moment of inertia Ix of a geometrical solid which is contained in a finite region E about x-axis is given by Ix is equals to triple integration over E rho x, y, z to y square plus z square dx, dy, dz. And similarly, the moment of inertia Iy, Iz about y-axis and z-axis can be formed. Okay. So, now if we let x bar, y bar, z bar be the centroid of the solid region, contained in a finite region E, then x bar is equals to triple integration over E rho of x, y, z into x dx, dy, dz by triple integration over E rho of x, y, z dx, dy, dz, and similarly for y bar and z bar. Okay, so these are the application. Now triple integrals involving rectangular parallelepiped. triple integral involving rectangular parallelepiped. Okay, so for this, when the region of integration R is defined by, this is R is A, B, this C, D and PQ. Okay, this is the length, breadth and height. This A less than is equals to X less than is equals to B, C less than is equals to Y less than is equals to D, and P less than is equals to Z less than is equals to Q. Okay, and if XYZ is bounded and defined in R, then the triple integral over R is defined as if XYZ dx dy dz is equals to, this is equals to integration of P to Q, then integration of C to D, then integration of A to B, f of x, y, z, this is over integration dx, then dy, then dz. Okay, so, and this is the integral, triple integrals involving rectangular parallelepiped, and if the region of integration R is a cube, then all is same here, all this length, height, length, breadth and height are same. So then when R is a cube, which is defined as AB, AB, AB. Okay, then triple integration over the region R, f of x, y, z, dx, dy, dz. This is equals to integration A to B. This is also same A to B. This is also same A to B. F of x, y, z plus dx, then dy, then dz. Okay, so this. Now, for example, say evaluate triple integration over R cos of x plus 2y plus 3z dx dy dz, where R being the region of rectangular parallelepiped. Defined as 0 less than is equals to x less than is equals to 2, 1 less than is equals to y less than is equals to 3, and mod z less than is equals to 1. Okay, so here triple integration over r cos of x plus 2y plus 3z dx dy dz, that is equals to, first x is defined from 0 to 2 dx, then y from 1 to 3 dy, then z from -1 to +1 at mod z less than is equals to 1, that means z between -1 to +1 cos of x plus 2y plus 3z dz. Okay, so this is 0 to 2 dx, 1 to 3 dy, this is 1/3 of sine of x plus 2y plus 3z -1 to +1. This means 1/3 of 0 to 2 dx integration of 1 to 3 sine of x plus 2y plus 3 minus sine of x plus 2y minus 3. Okay, this is of dy. That means 1/3 of 0 to 2 dx into, if we integrate with respect to y, this will be half of minus cos of x plus 2y plus 3, and this is plus cos of x plus 2y minus 3. Okay, this is 1 to 3. So this is of 1/6 integration of 0 to 2. This value is, when we put here x equals to 3, this will be, sorry, y is equals to 3 here, so that means 6 plus 9. So this is minus cos of x plus 9, and this value is plus cos of x plus 3. If we put here 1, this is plus cos of x plus 6, sorry, 5, and minus cos of x minus 1. Okay, dx. That means 1/6, this integration is, this is minus sine of x plus 9, and this means sine of x plus 3, this is sine of x plus 5 minus sine of x minus 1, 0 to 2. Okay, so from here it is 1/6. If we put here, this is 2, this is minus sine of 11 plus sine of 5 plus sine of 7 minus sine 1 plus sine 9 minus sine 3 minus sine 5 plus sine, this is 0, this plus minus, so this minus sine 1. Okay, so sine 5 is cancelled here, so we finally get 1/6 of minus sine 11 plus sine 7 minus 2 sine 1 plus sine 9 minus sine 3. Okay, so this is our answer. Okay, so in our next example, here the sphere as the region of integration. Okay, using the concept of triple integrals, find the volume of the sphere x square plus y square plus z square is equals to a square. Okay, so here sphere is the region of integration. So here x range from the first we draw the sphere. This is the region sphere is 0 x z y. Okay, so here x range from minus a to plus a, y ranges from minus root over of a square minus x square to plus root over of a square minus x square, and z ranges from minus root over of a square minus x square minus y square to a square minus x square minus y square. Okay, so the required volume V is equals to integration over region R dx dy dz, R being the region of sphere, so this is equals to minus a2 plus a dx minus root over of a square minus x square to a square minus x square dy, and minus root over of a square minus x square minus y square, a square minus x square minus y square dz. Okay, so first this is minus a2 plus a dx, this one dy, and after integration we get 2 into root over of a square minus x square minus y square dy. Okay, so this will be integration of minus a2 plus a, having integration of this value, we get a square minus x square of dx. Okay, you have to calculate it. This will be a square into x minus x cube by 3 minus a2 plus a, that means 4a cube by 3. So this is our volumes. Okay, now we discuss about the last example here. Evaluate triple integration over v over the volume dx dy dz, where v is a region bounded by the solid x square plus y square plus z square less than is equals to 1, x greater than is equals to 0, y greater than is equals to 0, and z also greater than is equals to 0. Okay, so here we draw the figure. Okay, this. So this is z, this is y, and this is x. Now here x square plus y square is equals to 1. This implies that y is equals to plus minus root over of 1 minus x square. Okay, so in the region of v, x varies from 0 to 1, and for any x, y varies from 0 to root over of 1 minus x square, and for any xy, z varies from 0 to root over of 1 minus x square minus y square. Okay, as it is this as x greater than 0, y greater than is equals to 0, and z also greater than is equals to 0, so our limit is this. So volume V is equals to this triple integration over V x plus z dx dy dz. This is equals to for x equals to 0 to 1 dx, for y is equals to 0 to root over of 1 minus x square, and z is equals to 0 to root over of 1 minus x square minus y square of x plus z dz. Here it is dy. Okay, so 0 to 1 dx, 0 to 1 minus x square dy. After integration, this is xz plus z square by 2. This is 0 to this. Okay, so by putting the value, we get x into root over of 1 minus x square minus y square plus 1 minus x square minus y square by 2, this dy, that is x equals to integration x equals to 0 to 1 dx after integrating. This will be x into first we rearrange this. X into integration of y is equals to 0 to root over of 1 minus x square, root over of 1 minus x x square minus y square dy plus half of 0 to root over 1 minus x square 1 minus x square minus y square dy. Okay, so this will be x will be 0 to 1 dx x into okay dx বাইরে লিখব so first x into y into root over of 1 minus x square minus y square by 2 minus 1 minus x square by 2 sin inverse of y by root over of 1 minus x square. Okay, this is the first integration here 0 to root over of 1 minus x square plus half of this value is y minus x square y minus y cube by 3. Half of y minus x square y minus y cube by 3. This is also 0 to 1 minus x square. Okay, this over integration dx. So x equals to 0 to 1. This x into, if we put the value of y here 1 minus x square, so this will be cancelled. Okay, so only we get this value x into this is the negative value okay sorry this is the positive value, so we get it x into 1 root over 1 minus x square no x into 1 minus x square by 2 into sin inverse of 1 we get it plus half of putting 0 all the values are 0 here. Okay, so from here half of we get root over of 1 minus x square minus x square into root over of 1 minus x square minus 1 minus x square into root over of 1 minus x square by 3 dx. That is x equals to 0 to 1 sin inverse 1 means pi by 2, so it is x into 1 minus x square pi by 4 plus root over of 1 minus x square by 2. This will common here, so we get 1 minus x square minus 1 minus x square by 3 dx. That is equals to integration 0 to 1 pi x into 1 minus x square by 4 plus root over of 1 minus x square by 2 into, from here we get 3 minus 3x square minus 1 plus x square dx. That is equals to pi x into 1 minus x square by 4 plus 1 minus x square by 2 into 2 into 1 minus x square by 3 dx. So this will be integration of 0 to 1 pi x into 1 minus x square by 4 plus 1 minus x square whole to the power of 3 by 2 by 3 this. over integration dx. So after integrating we get the value. This is pi by 8. This is your homework, you have to evaluate it. Okay, so next day we discuss about the line integrals.